All right, so this is the part 1 of the semester review. So here I'm going to just kind of write these answers out for each one. So x to the n is even, so that's going to be polynomial even. But we usually refer to this as quadratic. The graph is a U-shape. Domain is all real numbers, or negative infinity to infinity. The range is 0 to infinity. 0 is included with a bracket. This one should have asymptotes here. This is called the rational, so the equation is y equals 1 over x. It is called the rational function. All real numbers except x cannot equal 0. So for the domain, I'm going to do negative infinity to 0, union 0 to infinity. Notice the 0 is not included, and the range is the exact same thing. X to the n is odd, so this is polynomial odd. Or we refer to it as cubic. So the graph looks like that. So the domain and range are both all real numbers. Recall that you cannot put brackets on infinities because we don't know the exact value for them. This here is y equals c. We refer to this as the constant function. The domain is negative infinity to positive infinity. And the range is just this one number. I'm going to put it in braces because it's just one number only. This is the square root, it says, so y equals the square root of x. Closed circle right here, and it looks like that. So bracket 0 to infinity, and the range is going to be bracket 0 to infinity. All right, for the next one, it says this is the cube root function, because there's a 3 in there, so it's a cube root. This one looks like an S kind of. As you can see, the domain and range, negative infinity to positive infinity, to range negative infinity to positive infinity. So they're both all real numbers, or negative infinity to positive infinity. This here makes a V, so that has to be the absolute value. So y equals the absolute value of x. The domain, if you take a look, negative infinity to positive infinity, so that's from left to right, negative infinity to positive infinity. Range is bottom at 0 to infinity, so bracket on the 0 because it is included. This is e to the x, that's exponential. The graph has an asymptote on the x-axis, and it starts small and gets big quick. So the domain is all real numbers, so negative infinity to infinity. And the range is from 0 to infinity, but that asymptote we don't include because you're not cross or touch it, so 0 to infinity. Logarithmic, y equals log base b of x. That's like an upside down L, and we do have an asymptote that is at the x or the y-axis. So domain is going to be 0 to infinity, 0 not included. The range is going to be all real numbers. So notice these are inverses because they're flipped around. They're reflected across the line y equals x. This one here, y equals x, that's the linear function. So from left to right, it does rise up. So the domain and range are both all real numbers. All right, for these, we're going to do domain and range. It says, given the following functions, name the domain and the ranges. Okay, so domain is from left to right. So furthest left is this arrowhead. Furthest right is this arrowhead. And you see that it is continuous, so we can draw it all the way along. So this heads towards negative infinity. This heads towards positive infinity. And we put parentheses on that. For the range, the lowest part of the graph appears to be this part right here. The highest part, we have 2 arrowheads that go towards infinity. This is -1, -2, -3, and this heads towards infinity. So least to greatest, so -3, comma, infinity. Parentheses on the infinity, and closed circle is a bracket. For this one here, we can see this heads towards negative infinity, and this heads towards positive infinity. For the range, it heads down to a negative infinity. This goes up to positive infinity. So the domain and range are both all real numbers. For the next one, we have a closed circle right here. It's connected all the way into this open circle right here. So the value is -1, -2, -3, -4. This is 1, 2, 3, 4. So we have -4, comma 4, bracket and parentheses, closed circles bracket, open circles parentheses. For the range, this bottom part is right here. So a closed circle at -1, -2, -3. Highest part, there's 2 endpoints, but this is the highest one. So open circle, 1, 2, 3, 4. So least to greatest, closed circle is a bracket, open circle is a parentheses. All right, on to the next page. All right, for here, it says to find the range given the specified domain. So for here, I'm gonna plug the numbers in and I'm gonna use a calculator. So like for this one here, it says 2x squared plus 3, domain is x, right? So it's asking me to find the range, which is y. So I just plug this x in for this right here. So 2 parentheses -2 squared plus 3, 2 parentheses 0 squared plus 3, 2 parentheses 3 squared plus 3. And now you can type this into a calculator. I have this here, so I'm probably just going to use Desmos real quick to plug it in. So you can go to Math Tools from Desmos.com, go to Scientific Calculator, and we'll just type these in. So hopefully you can see what I'm typing in there. Plus 3. So there's the first one. There's the second one. So my values are 11, 3, and 21. We're going to put those in numerical order. So ascending, 3, 11, 21. So right here we have braces, 3, 11, 21. All right, for this next one here, it says find the domain given the specified range. So this time they give you the y values, which means we're going to change f of x to each one of these. So we'll start with 1/3 x minus 1 is equal to -1. 1/3 x minus 1 is equal to the next number, which is 5. And then 1/3 x minus 1 is equal to 9. All right, for this first one here, we're going to go ahead and add 1 to both sides. So 1/3 x is equal to 0. I like to multiply by the reciprocal, which is 3. You can also divide by 1/3. Just make sure you use parentheses correctly. So 0 times 3, x equals 0. For the second one, we're going to do the same process. We're going to add 1 to the other side. So 1/3 x is equal to 6. Multiply by the reciprocal, which is 3. So x is equal to 18. And then the last one, add 1. So 1/3 x equals 10. Multiplied by the reciprocal, which is 3. And 1/3 is x times 3 is x, and then 10 times 3 is 30. So numerical order, braces, we have 0, 18, 30. All right, from here it says Susie tossed the ball into the air. What is a reasonable domain for the amount of time that the ball is in the air? So time, we know we cannot have negative time because we can't go back in time. So all real numbers includes negative numbers, so that's not correct. This has a -10, so therefore that cannot be correct. And this one says from 0 to 10 seconds, that is reasonable. All right, describe the effects of the transformations of the graph. So you may want to reflect back on your notes for transformations. I'll do a quick review here. If a is greater than 1, that's a vertical stretch by a. If a is less than 1 but greater than 0, that's a vertical compression by a. If a is less than 0, which means it's a negative sign, that's going to be a reflection across the x-axis. We have h. If h is greater than 0, it goes to the right. If h is less than 0, it goes to the left. If k is greater than 0, it goes up. If k is less than 0, it does go down. Okay, and there is a b value, but if we get there, we'll talk about that. Or when we get there, we'll talk about that. So describe the effects. So if you don't know the general equation, it looks something like this. Okay. So notice that this is in the place of a. So this is greater than 1. So if a is greater than 1, it's a vertical stretch by the number. So vertical stretch by 6. This is outside the parentheses, and it's minus 3, so it's a k. K is less than 0, so it's down 3 units. For the next one, there's a negative on the outside, which is a, so less than 0 is a reflection across the x-axis. And this k is on the outside, so it's a positive, so up 3. Over here, this is inside the parentheses, so it's the opposite of what you see. So it doesn't really go left 4, it actually goes to the, because when you pull it out, h is the opposite, which is 4, so that's going to be right 4. So based on our previous one, it's the opposite, so this looks like it goes right 5, the opposite is left 5. This is outside of the parentheses, so it's less than, so it goes down 4. All right, for these right here, number 7, it says the graph of y equals f of x is given below. Write an equation for the graph right here. So it's really looking for the transformation. So I just pick any point on here. I'm going to pick this endpoint, and it's transformed to this endpoint. So this is at 1, 2, negative 1. So I'm going to plot over here 1, 2, negative 1. And I'm going to see the transformations it took to get from this red dot to this one. So we go and write 1, 2, 3. So we went right 3. And then we go down 2. So one of these function notations has the transformations of right 3, down 2. This one says left 3, so therefore it's wrong. This one says right 2, which cannot be. We're looking for right 3. This says right 3 and down 2, and that's our answer. All right, this one says to solve the following system's equation using any method, okay? So let me go ahead and talk about the types of solutions you have. The first one is if you just have this actual solution, so we'll call that one solution. So when you work it out in the matrix, it would look like this: 1, 0, 0, and then whatever the constant is, 0, 1, 0, whatever this constant is, and 0, 0, 1, whatever that constant is, okay? So you'd have to have x equals this number, y equals this number, and z equals this number. These are all different numbers. Maybe I should just use something, but I just use c. So your answer would be like something like this. And whatever they are, guys, I don't know what it is, but that would be your solution. The second type would be, let's say, a no solution. And this is going to deal with the third row. So you're going to look at the third row. So it's going to look something like this: 1, 0, 0, and then some constant, 0, 1, 0, some constant. Then you're going to have a false statement: 0, 0, 0, 1. So when you go down diagonally, you see the 1, but then you see a 0, and you notice that this is not true, right? Zeros and then a 1. So what that says is that 0 does not equal 1. That's no solution because it's false. And then for the last one, it's going to be infinitely many solutions. And again, you're going to look at the third row. If this one was false, then the infinitely many solutions is going to be a real thing. So 1, 0, 0, some constant, 0, 1, 0, some constant, and 0, 0, 0, 0, okay? So notice in the third row, these is 0 does equal 0, which is true. And that's how you get infinitely many solutions. So notice we know that x is this number, y is this number, but there's no z here. And then you look, there's no x, y, or z, so it's just 0 equals 0, which is a true statement. All right, so now we have these. The first thing you need to do is make sure they are in standard form. So this one is good: x plus y plus z equals 3, negative x plus 3y plus 2z equals 12. This one is incorrect, so I'm going to put them in order. So the x should be right here. There is no y, so I'm going to put a 0, or you can leave it blank. And then the 4z needs to move over, so I'm going to subtract 4z. And when you subtract 4z, there's no more constant, so it's just a 0. So I'm going to write my augmented matrix. So use the coefficients 1, 1, 1, and then the constant is 3. The second one, negative 1, 3, 2, and the constant is 12. And then we have 1, 0, negative 4, and the constant is 0. Okay, now we're going to go to our, either you can type this in the calculator and do it, but let me show you how this looks in decimals. So once again, if you go to Desmos and you go to Math Tools, you can do the matrix calculator, and you're going to do new matrix. You're going to change it to the number of rows, so it's 3 rows by 4 columns. Then we're going to start by typing in our numbers. So right here, I see one. Let's see, I see 1113. Then the next one is -1, 3, 2, 12. And in the last row, we have 1, 0, -4, and 0. Okay. Now we're going to type our ref, so the bottom left. And then our matrix is A. And notice we see these decimals, so if you just hit the little fraction to the right side, it converts them to a fraction. Now, take a look at the bottom row, 0, 0, 1. So I see 1, so x equals this number, y equals this number, and z equals this number. So I'm going to go ahead and write my solution down. So my solution for this particular one, in ordered triple form, is -12 over 17, 66 over 17, and -3 over 17. All right, for the next one, we notice that everything is already in standard form, so I'm just going to write my augmented matrix. So 4, 5, 3, 11, 1, -3, 1, 6, -2, 6, -2, -12. All right, and then we're going to do this again into here. So I'm going to do a new matrix. It's again 3 by 4. So 4, 5, 3, 11. Then we have 1, -3. 1 and 6. And then we have -2, 6, -2, -12. Okay, then we do our ref, matrix A, and then we have this here, so let's make it fractions. But what I noticed first off is on the bottom row, 0, 0, 0, and 0, okay? So this means that 0 equals 0. So according to what we just talked about, if 0 equals 0, that is a true statement. So my answer is infinitely many solutions. All right, let me keep moving on here. For here, it says a scholarship award was given to the student who was awarded the most points, and a different number of points are given for each first, second, and third place vote. The table shows the values for the top 3 finishers. Find the number of points awarded for each vote. Okay, so I do like these because they are set up nicely for you. So let's start with X, Y, and Z. X is the number of points awarded for first place. Number of points awarded for first place. This is Y is going to be the number of points awarded for second place, and then this will be the number of points awarded for third place. Now the equations are pretty much set up. This is the X column, the Y column, the Z column. This is my totals, and then you're just going to add up each one together. Oops, sorry. So these are the ones I like because you're just going to add them together. So 23x plus 8y plus 1z is equal to 141. And so they're pretty much set up for you. So my first equation, 23x plus 8y plus z is equal to 141. 8x plus 18y plus 3z is equal to 100. And x plus 3y plus 5z is equal to 24. I'm not going to plug it into the calculator for you. You can do that yourself. Let's take a look at number 10. It says Michael has a jar full of change with nickels, dimes, and quarters that is worth $5.15. He has twice as many quarters than he has dimes. There are 49 coins in the jar. How many of each coin does he have? So once again, we're going to use X, Y, and Z. So how many of each coin? So number of nickels, number of dimes, number of quarters. Okay, so my first one, let's talk about the total number of coins. There's 49. So x plus y plus z is equal to 49. Now we're going to talk about the total amount of money. Well, we know a nickel is worth 0.05. We know a dime is worth 0.10. So 0.05x plus 0.10y plus 0.25z for a quarter is equal to $5.15. Now for the third equation, it says he has twice as many quarters than he has dimes. So he has more quarters, and quarters is z, so we're going to say z equals. And it's going to be twice as many, so 2 times dimes, and dimes is y. So z equals 2y. Now, when you are putting this in the matrix, you want to move the y over, so it would be negative 2y plus z is equal to 0. And once again, I'm going to let you type that in and get the answers. I'll provide those in a bit. This one says to solve the following system of inequalities by graphing. So for this one here, all you do is add the x over. So y-intercept is at 3, and my slope is positive 1 over 1, so up 1, right 1, down 1, left 1. And now before I graph it, let's go ahead and talk about this. So you can have 2 types of, or 4 types of line. It can be solid or dashed, and you can shade above or below. So solid and above is greater than or equal to. Dash and above is just greater than. Below and solid is less than equal to. Dashed and below is just less than. So here we can see it's less than right here, so it's going to be dashed, and you're going to shade below. So it's already, we're going to make it a little bit more dashed, and we shade below. For the other one, we solve it, so we would subtract 4x from both sides. Make sure you only take it away if they're like terms, which they're not. So I put the x first. Then we're going to divide by 2 every single thing. And you only flip the inequality sign if you divide by a negative. So y is less than or equal to negative 2x minus 1. So my y-intercept is at negative 1. My slope is negative 2 over 1. So I go down 2, right 1. And then up 2, left 1. So we go over here. We see that it's this symbol here. So it's less than or equal to, so it's going to be shaded below, and the line will be solid because there's an equal bar. So your double shaded region is your solution set to the systems of inequalities. All right, now to the next one. Here it says, tell whether the ordered pair is a solution of the inequality whose graph is shown, circle yes or no. So let's start with the point 0, negative 2. So 0, negative 2. So notice it falls on this point, on the graph, where it's a solid and a dashed line. So it will satisfy the solid line, but the dashed line, it's never going to work. So therefore, this is not a solution. For the next one, 1, negative 4. So 1 and negative 4. Notice it does fall in the triple shaded region. So that is a solution. And then 3, 1, 1, 2, 3, and 1. You can see it's nowhere close to this double shaded region. So this is not a solution. Now it says to write a system of inequalities below. So those are going to be in the form y equals mx plus b, okay? So for this, this symbol right here is going to be one of these right there. Okay. So let's start with this one. Let me change color. Let's start with this one right here. So we're going to start with y, and it is solid, and the shading is below. So solid and below is less than or equal to. So we have to do the slope. So I see this nice point. It goes up 1, 2, 3, and over 1. So 3 over 1 is 3. And my y-intercept is at negative 2. For my second one, I will do this line right here. So we have this nice point here, and let's see if we can find the other nice point right here. So we go down 2 and right 2. So let's start with y. It is a dashed line, and it's below. So dash and below is less than. And we just figured out that it's down 2, right 2, so negative 2 divided by 2 is negative 1x, and my y-intercept is also at negative 2. Then for our last one, we'll do this line here. So we start with y. The shading is, it's dashed and it's shaded above, so dash and above is this, greater than. For my slope, I can start here and go to here. So down 1, and then right 1, 2, 3, 4, 5, 6. So negative 1/6 x, and my y-intercept is right here at -5. Okay, so really quickly, if I start here, I go down 1, then 1, 2, 3, 4. It should be -1/5. Sorry about that. All right, down to the last page here. So let's talk about these. It says, given the graph of f of x below, find the following. So for the first one, it says find on what intervals of x is f of x constant. So that means from left to right, the line is horizontal, so it remains the same. An example is just like this. Okay, so right here I can see it's from here to here. So this is -3 and this is -1. So -3 comma -1, and you're going to always see me use parentheses. I'll tell you when I use brackets. So that's my constant part, nothing else is constant. One intervals of x is f of x increasing. So from left to right, the graph goes up. So it should look going up like this. So that's going down, that's constant, this is going up. So it's going up from x value of -1, and it stops going up at this x value of +2. So -1 comma 2, and I'm going to use parentheses. For the next one, on what intervals of x is f of x decreasing? So from left to right, where is your graph falling or going down? So that would look like this. So it's actually in two places. So this one is heading towards -infinity, and it decreases all the way down to this x value of -3. So we have -infinity to -3. Union, because there's another part, it's falling from here, which is at +2, and it stops at 6. Now what I want you to know is I'm going to put a bracket on the 6, right? Because that's an endpoint. So the starting points and endpoints can have brackets, and it depends. If this closed circle is here, which it is, that's why it's a bracket. If it was an open circle, it would be a parentheses, and if it was an arrowhead, it would obviously go to infinity. All right, and for the next ones, it says on what intervals x is f of x positive. So this is asking positive, where is the graph above the x-axis? So if this is the x-axis, where is it above? So we can see that it's above at -infinity, and it stops right at this point right here, which is at -4. This is negative because it's below, and then at this point here, at 0, it starts going positive because it's above, positive, 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 and it stops at 6. So we have from 0 to 6. So those are what those are, -infinity, -4, union 0 to 6. Now, even though 6 is a closed circle, it's on the x-axis, and the x-axis for this problem is considered neutral. So I put a parentheses on it to show that it's not included. All right, for the next one, what intervals of x is f of x negative? So this one will be below the x-axis. So here's the x-axis, and it's everything below it. So we already know that this is -4 to 0. So this is below the x-axis, so it's -4, comma 0, and we don't include it because the x-axis is neutral. It's not positive or negative. Now for these next ones, let's go and use this one here. It says f of 0. So remember, this is f of x is equal to y. So they're giving me an x value. So x is 0, and at this point, what's the y value? Well, it's on there already. It's already hitting the graph, so the y value is 0. For this one, f of -3. So usually I just draw lines through it, and you can see it hits the graph at this point here, and the y value corresponds to -2. Now this one, this is a y value. So they're asking me to find x. So I'm going to go to the y value of 2, and I'm going to draw a horizontal line through here and see where it hits the graph. Not lines I've drawn, but the graph. It hits the graph at this point here, which is at -5. It hits the graph here, which is at +1. And it hits the graph here, which is at +4. And those are my solutions there. And f of x equals 4. So here's 3, 4. So once again, we draw a line through here. And we see it hits at this point and right here. So this looks like -6 and positive 2. And I know there's a lot going on there, guys, but just rewatch it. This is negative 6 and positive 2 for your x values. From here, it says graph the system of inequalities and its solution set. So for this first, this one, I'm just going to graph it because it's already there. So we start at negative 2. My slope is down 1 and right 2. Down 1, right 2. And then up 1, left 2. And that's a solid line. And you shade below. All right, and then last but not least, this one you're going to solve it. So negative 2y is greater than, subtract the 8x. When you divide by the negative 2, that does flip the sign. So we start at negative 2, and this time we go up 4, right 1. Down 4, left 1. And it's a dashed line. And since it's less than, we shade below. And so we figure out which point falls in there. So negative 4, positive 1 does not. Negative 2, 1, 2, 3, 4, 5, 6 does not. 3, 1, 2, 3, 4, 5, 6, 7. This does fall. And 4, 2, 1, 2, 3, 4, up 2. That does not. So the only value that falls in there is B. And I will continue this on with part 2.